Hello and welcome back. Here's another segment of graphing sine functions and cosine functions as well. We're going to be talking about amplitude and also period. However, the last couple of videos we talked about graphing sine and cosine functions using transformation. But we're going to do a little something different on these videos to come. So watch closely. We're going to be talking about the sinusoidal graphs and the shift of the graphs of y is equal to cosine x to the right of pi over 2 units to obtain the graph of y is equal to cosine parentheses x minus pi over 2. That reminds you of something, doesn't it? Reminds you a little bit of a horizontal shift in the graph. But look at the graph in figure 1, and within figure 1 here, we want to look at the graph y is equal to sine x, and in figure 2. And then we see the graph of y is equal to sine x is the same as y is equal to cosine x minus pi over 2. So you see figure 1 here, and you see figure 2 here, respectively. And what we have is some sort of shift here in the graph because of x minus pi over 2. Horizontal shift, that is. Okay, and as you can get a nice good look, you can see the details here. Now, based on figures 1 and 2, we can say that sine x is equal to cosine x minus pi over 2. Because of this relationship we have between the graphs forming y is equal to a times the sine of omega times x, and y is equal to a times the cosine of omega times x. These are referred to as sinusoidal graphs. See this? So we want to determine the amplitude and the period of the sinusoidal functions. So when you look at this here. As you see y is equal to cosine x, we notice that its amplitude is 1. Because if you see right here, that's understood to be 1 there. However, or a, right, which is equal to the amplitude, 1, is all the values here, as you see, between -1 to 1. And if we multiply by 2, we get what? Remember from the last videos, we get a vertical stretch by the factor of 2 right here. Because of the amplitude here being, in this particular case, 2. So, if we see this, this is going to be what? Y is equal to 2 cosine x. You see this? Because of the vertical stretch, as you see. Now, we can say that y is equal to sine times omega x, and y is equal to, well, y is equal to a times sine omega x, and y is equal to a times cosine of omega x, where a cannot equal 0 now in this particular case. It will always satisfy the inequalities as a negative absolute value less than or equal to a sine x less than or equal to the absolute value of a, or negative the absolute value of a less than or equal to a cosine x less than or equal to the absolute value of a, respectively. So the number, the absolute value of a, is the amplitude of what? Of y is equal to sine x, and y is equal to cosine x, as you see right here. And let's go and look at a few more things here with the graphs. We have y is equal to cosine x, as you see respectively. And then we have y is equal to what? Cosine 3x, right? So we can say if omega is greater than 0, the function y equals sine omega x, and y is equal to cosine of omega x, we'll have a period t is equal to 2 pi divided by omega. So the graph of y is equal to sine of omega x is obtained from the graph of y is equal to sine x by performing a what? From last time, the video that we spoke about before, a horizontal compression or a stretch factor of what? 1 over omega. Now this horizontal compression replaces the interval 0 to 2 times pi, which contains one period of the graph of y is equal to sine omega x. And so the function y cosine 3 times x graphed right here is graphed in figure A. Figure A, see, with omega here equal to what? 3. And that has a period of 2 pi divided by omega, which is equal to what? Omega being this value here, and 3 replacing that value, so it's going to be 2 pi divided by 3. So look at the graph here. As you notice, y is equal to cosine x. And then, as we look here, we see that this is represented by omega. So here, you're going to take that value and plug it into omega, and that's going to be 2 pi divided by 3. And that is our period. And this piece here, from here to here on the graph. Now, let's talk about this for a second. When graphing y is equal to sine omega x, or y is equal to cosine omega x, we want omega to be positive. And to graph the y is equal to sine negative omega x, we want omega to be greater than 0, or y is equal to cosine of negative omega x. We want, again, omega to be greater than 0. We want to use the even and odd properties of sine and cosine functions. And this is as follows, remember this? Sine of minus omega x is equal to negative sine of omega x, and cosine negative omega x is equal to, this is an even function, isn't it? Cosine of omega x. And this gives an equivalent form in which the coefficient of x is what? Positive, like we said. And then sine of negative 2x is equal to negative sine of 2x, and cosine of negative pi times x is equal to cosine pi times x. Because of this, we can assume that omega will be greater than 0. Now, for right now, this concludes this segment of the video, and then we're going to continue on talking more about the amplitude and period of a function.